Hi, algebra students. Our goal today is to be able to simplify, add, subtract, and multiply radicals. This first one, what we want to do is we want to be able to simplify the square root of 99. I'm sorry, I don't have the direction there to simplify, but we do want to simplify that, okay? When we simplify that, we prime factor it. So we have 11 times 9. 9 is already, 11 is already prime. So I'm going to factor 9. That's 3 times 3. And now what I like to do once I've factored it all, just for organization's sake, is I like to write them all under that root again. So 3 times 3 times 11 makes up 99. Now what I want to do next is I want to look for pairs of any numbers, or so pairs of numbers. So I have a pair of 3 right here. Why am I looking for a pair? I'm looking for a pair because I'm dealing with a square root. So I'm looking for pairs. Okay, anytime we have a square root, we're looking for pairs. Because I have one pair of 3s, I get to cross this off and bring 1 3 out because I had one pair. There's an 11 left over that is not a pair, so that stays inside of this root. So I'm left with 3 times the square root of 11. And this is simplified. This gets a little bit more difficult today. Okay, well, we'll keep getting more difficult, but this one gets a little more difficult because we have the square root of 200, x to the 5th, y to the 7th, and z. Now, to preface this, there are several different ways, or a couple different ways, I should say, that you can solve this. And if you have a faster way that you can solve this, you can go out and do that and check with your teacher, okay? But we're going to keep going, and we're going to be looking for pairs because we're dealing with the square root. So 200, if I factor that, 200 is 2 times 100. And 100 is 10 times 10. Now, do you notice here I actually have a pair? Okay, so I'm going to stop because I'm looking for pairs. And then what I can do is I can bring that 10 outside. I'm not going to do it yet because I like to rewrite everything under the root like I did over here. So I'm going to do that right now. I'm going to say, okay, I know that 200 is 2 times 10 times 10. Okay. I know that I have a pair of 10s, one pair of 10. So I'm going to bring that 10 to the outside. 110 because one pair. But look here, guys. I still have this x to the 5th, y to the 7th times z. So what I'm going to do is I'm going to write this out. I have x times x times x times x times x. I have y times y times y times y times y times y. One more time, let's just check. Times y. And then finally, I have z. I want to look for pairs now with my variables. I have one pair of x's, two pairs of x's, and then one single x. That means I'm going to bring, since I have one pair of x and then two pairs of x, I'm going to bring these out here. Okay. And what we do out here is we multiply all of the stuff that comes out here together. So that's going to be 10 times x, which is x to the 2nd power. Okay, so I'm staying a little more organized below here. Now let's look at the y's here. I have one pair of y's, two pair of y's, three pair of y's. So 3 y's get to come out. Okay. It's looking a little messy. I don't like that. I'm sorry. When those 3 y's get to come out here, I multiply those all together. So y times y times y gives me y cubed. Okay. Then finally, I look at the z, and there's no pairs with the z. Okay. So now that I've taken everything outside of the root that gets to go outside because there was a pair with it, I say, well, what's left over? I have a 2 left over. I have an x left over right here. I have 2, let's see here. I have one y. That looks a little bit bad there, guys. I'm sorry. One pair, two pair, three pairs. I have one y left over. And I have one z left over. Now, again, just to sum what we did up, we factored this. We looked for pairs. The pairs get to come outside. What did we learn? Everything that comes outside gets multiplied together. We had two pairs of x's, so x times x is x squared right here. We had three pairs of y's, so y times y times y comes outside. That's y cubed. And then we leave whatever's left over inside that radical. Let's move on. Now, what's different here about these problems here? These are all cubed roots. So instead of looking for pairs, we're actually looking for groups of 3. So not groups of 2, which are pairs, but groups of 3. So let's start over here on the cubed root of 16. And when I do this, I'm going to say, well, that's 2 times 8. Okay? 8 is 2 times 4. And 4 is 2 times 2. So now I'm going to rewrite it to stay organized. Now pay attention to what are your primes. 1, 2, 3, 4. A common mistake is sometimes people will put like 2, 2, 4, 2, 2. Like you want to see what is at the end of your branches and it doesn't have any other branch with it. Okay, so I have 4 2s. 1, 2, 3, 4. Now, again, I'm looking for a group of 3, and I have a group of 3 right here. Okay, the group of 3 that I have is I have one group of 3, and that is a 2. Okay, so the group of 3 that I have is a 2. That gets to come outside now, that cubed root. And these go away. So to simplify the cubed root of 16, I'd say 2 times the cubed root of what's left over. And that's this 2 right here. This is my final answer for simplifying the cubed root of 16. Okay, let's move on to the next one. Okay, what I did here is I pulled up my calculator for those of you who maybe struggle a little bit with division or thinking about what the factors are. So let's just talk about this real quick. So what I want to do right now is I want to figure out what are the factors of 75 and factor that like that factor tree that we've been doing here, okay? So 75 divided by 5 works. So you can try to do things to figure out, like if you don't know what it is. And look, 75 divided by 5 is 5 times 15. Okay, 5 we know is prime, but 15 is not. If you're struggling, just go ahead and like use that calculator. Because say like 15 divided by 2, does that work? 15 divided by 3. Hopefully you know that 15 divided by 3, that 15 is 3 times 5. But I just wanted to bring that up there to show you that you can use that calculator to test certain things out. So I know 70, and whatever you divide it by, then that this 5 here and 15, that's your factor pair there. 5 is prime, so we went on to 15, that's 3 and 5. I'm now going to rewrite it, okay, the cubed root. And I'm going to write my pairs together. You see we have a pair of 5, so I have 5 times 5 times 3, okay? Now I have the variables again that we're dealing with, okay? So I have 5 x's and I have 6 y's. Okay, again, guys, I'm looking for groups of 3, okay? I see I have 2 5s, but that's not a group of 3. I have 1 3, not a group of 3, but I do have a group of 3 right here and no other groups of 3 with the x's. I have one group of 3, that's a y, and I have another group of 3, that's a y. So what gets to come out of this cubed root? The 1x, because I have one group of 3 x's, okay? Then I have 2 groups of 3 y's. So remember what I said, when they come out, we multiply them and we put them out here. So that's y squared. What do I have left over? I have x times y squared times the cubed root of 5 times 5 times 3, which is 75. Okay, let's move on to the next one. How is this one different than the other ones? Well, it looks a little bit easier because it doesn't have the variables maybe, but it has this number on the outside, so I want to address that as well. Okay, because 625 is a bigger number, and some of you that might scare some of you off, we're going to take 625, and I know that 5 does go in it, so I'm going to divide by 5, okay? So now I know, okay, 625 is made up of 5 and 125. Okay, if you're struggling still with this 125, like that scares you, but that's okay. But we're just going to take then 125, and we know 5 goes into it again. So let's see what happens. And that's 25. And hopefully at this point you know that, well, 25 is 5 times 5. But if you don't, that's okay. Let your calculator help you out there. Okay, again, I like to rewrite it to stay organized. So I have a 6 times the cubed root of 5 times 5 times 5 times 5. All right, ladies and gentlemen, remember what I'm looking for, groups of 3, and I have one group of 3, which is a 5, okay? I get to bring that outside, and this is gone now. Okay, when that comes outside, well, I have this other number here. What do I do with it? Remember, anything on the outside, we multiply those together. So 5 times 6 is 30. 30 times the cubed root of 5. Okay, let's move on. We did square roots, we did cubed roots. Now we're going to go on to multiplying radicals together. Let's look at this first one together, okay? There's a couple different strategies you can do when you're doing this, but what I like to do is I like to write it all as one first, okay? And then what I like to do is I like to put the numbers together and the variables together. So 14 times 7 times x squared times x, okay? And this is a property that we can do this. When we're multiplying radicals, we can take, as long as they have the same root, so this is a square root, we can take what's inside and multiply them together and make it one root, okay? That is a property. Now what I'm going to do next, because I want to simplify it, is I want to go ahead and I want to prime factor these. So 14 is 7 times 2, okay? And then x squared here is x times x. And then this x here and this 7 here as well. Okay, so I'm going to write it all as 1. So I have a 7 times a 2 times a 7. So since I have two 7s, I'm going to put them together. 7 times 7 times 2 is the same as 14 times 7. Then I'm going to write x times x times, and then this final x. Again, now just ask yourself, what is, we call this the index. Like, is there an index out there? There's no index out here, so that's a square. But like on this problem, this is an index, that's a 3. So we have a cubed root. So that's how we knew we were looking for groups of 3. If this was a 4, we'd be looking for groups of 4. A 5, we'd be looking for groups of 5. The process is all the same. You just have to ask yourself, what is the index? Okay, so now we have this square here, we know, so we're looking for groups of 2. I have one group of 2 here, that's a 7. I have another group of 2, that's an x, and that's it. So I take 1 7 gets to come out, and 1 x gets to come out. I'm going to cross those off because they're gone. So on the outside, that multiplies together, 7x times the square root of 2x. Why 2x? Because that was what was left over. Okay, let's move on to the next one. This one looks a little more difficult because we have some negatives on the outside of that radical. What I'm going to do, again, is I'm going to write this all together. I'm going to take the numbers that are on the outside and I'm going to put these on the outside. Times the square root of 44 times 20. So what's inside of the radical goes inside of the radical in 1, and what's outside goes outside of the radical. Okay, I know that -5 times -4 is -20. I'm sorry, it's +20, forgive me. Okay, because a negative times a negative is a positive. And now what I want to do is I want to prime factor again. Now I maybe was a little too quick here. I'm going to bring this down a little bit. All right. 44 is 4 times 11. 4 is 2 times 2. I'm a touch scrunched, forgive me. 20 is 2 times 10. And 10 is 2 times 5. I'm going to take all of these prime factors now, and I'm going to write them under the radical. That is 2 times 2. I'm going to cross these off because I'm done. I'm also going to put these 2's by them as well, times 2 times 2. I like to cross things off when I'm done with them, just an organization thing. And then this 11 I can't forget about. Just really pay attention to details, guys. And 5, you don't want to miss anything. Okay, I'm looking for groups of 2. How do I know? Because it's a square. I have a pair here of 2, a pair here of 2. That's it. So I bring 1, 2 out for this pair, for this first pair, and these other 2 out for this second pair. It looks messy. Forgive me. I'm using my mouse at home here. I'm not on my iPad, which I normally am. Now I take 2 times 2 times 20. Okay. 2 times 2 times 20 is 80. Times the square root of what's left over. I'm going to cross this off because I'm done. What's left over is 11 times 5, and that's 55. Okay, let's move on. Now we're to the fun stuff, guys. We're to the adding and subtracting of radicals. This can get a little bit more difficult for some of you, but I want you to go back to this first problem. You'll notice there is no radical here. It is 7x squared minus 10x squared. Back in pre-algebra, Algebra 1, you learned that like things go together, and you can only combine when my square, like x squared and x squared match. They're like terms. 7 minus 10, well, that's negative 3x squared. The same goes for this problem here. Here I had 7x squareds. You can imagine almost, 7x squareds together and then 10x squareds together, okay? I do 7 minus 10, that's negative 3x squareds together. Now I have 10 square roots of 2. And I have 3 square roots of 2. Together, how many square roots of 2 do I have? 13 square roots of 2. These are similar to like terms. They're just like radicals. Like terms go together, like radicals go together. Okay, and we just do the operation that we see when the radicals are alike. Now, if you notice here, though, guys, square roots of 12 and square roots of 3, these radicals are not alike. But what we can do is we can simplify the square root of 12. The square root of 12, well, if I prime factor it, that's 4 times 3. And then 2 times 2. When I simplify that, 2 times 2 times 3, I have one pair. I'm going to bring 1, 2 out then. That gives me 2 times the square root of 3. And then over here, guys, don't forget, pay attention to details. I have plus 3 square roots of 3. Well, now I have like radicals right here. So I have 2 square roots of 3 plus 3 square roots of 3, which gives me 5 square roots of 3. Okay, so what did I just learn there? If they're not alike, see if you can simplify one of the radicals. And if you can, then check and see if they're alike and combine them. If they're not alike, then you're done with the problem. Let's go on to our final problem, guys. I wanted to get a subtraction one in there as well for you. And one where we look at it, we have to simplify both of these. On this last problem, square roots of 3, we can't simplify. But that's just another thing we need to learn is to check to make sure that they're simplified. So the square root of 12, let's simplify that. That's the square root of 4 times the square root of 3. 4 is 2 times 2. I have prime factored it now, and so I have 4 on the outside times 2 times 2 times 3. I have one pair of 2. I'm going to take that one pair of 2 out. So I take 1 2 out. This goes away.